Hello, you are all welcome to this channel. It's been a while since our last lesson. Yes, quite a while, but we are fully back to complete the CompTIA N+ networking course. In our last lesson we learnt about the TCP-IP models and how useful they are in communication. Taking a quick recap, we learnt briefly about what protocols are, and taking into consideration, we started with the TCP-IP. We learned that TCP-IP are two separate computer network protocols. Having explained that, we also learnt some brief history about these protocols, their meanings, and how they function. If you haven't watched the previous lesson, I highly recommend that you watch it before continuing with this one. Coming back on today's lesson, we are going to learn about IP addressing. Now, explaining what an IP address is, this could be done in layman's perspective as well as technical perspective. In layman's perspective, we can say that an IP address is a numerical label assigned or given to devices on a network. Now, just like students having unique index numbers to identify them in the exams hall, so do computers, and some devices on a network are also given unique numbers in order to reach them and to communicate with each other. Digesting this analogy, we can further say that students may be having similar or sometimes same names, so, in order to identify each student exams paper, we therefore assign a unique number, known as index number, to each student in a particular order. We can apply similar techniques to devices on a network, but this time in a specific order and format. So, technically, we can say, an IP address is a 32-bit number assigned to each host on a network. Now, going further, when we take a student's index number, we can split them apart. We can have the school's ID or number, indicating the center or school that such student attends. Again, we can have the part that identifies the student as he or she sits for the examination. Applying same analogy here, IP addresses can also be grouped into parts according to their versions and classes. In this level of the course, we are going to concentrate much on the IPv4 addressing, also known as the IPv4 address. Now, going back to why I made mention of the 32-bit number above, this IPv4 address is written in binary in 4 octets, each of which is 8 bits. In a few moments, I will show you how you can assign IP addresses to devices on the network, but for now, let's concentrate and understand the concept of IPv4 addressing. As I explained in the binary lesson, this address is usually written in decimals, each of which can have a minimum value of 0 and a maximum value of 255. If you have not watched that lesson, I will entreat you to watch it in order to understand how these values are converted into binary and vice versa. The link is in the description below. So, in this example, these are the corresponding binary values of these decimal numbers. Each binary value here is called a bit, and 8 of them is known as byte or octet. Now, explaining further, these IPv4 address are classified into 5 classes. 1. Class A address. 2. Class B address. 3. Class C address. 4. Class D address, and lastly Class E address. Delving deeper, let's see how these groupings are done. When we consider the decimal values 0 to 255, Class A address begins from 0 to 127. Class B address begins from 128 to 191. Class C address begins from 192 to 223. Class D address begins from 224 to 239. And lastly, Class E address begins from 240 to 255. Now, you may be asking, how can one see and identify each class? Okay, this is simple. How you can identify this is that only consider the value of the first octet and check where it falls within the ranges. Now, let's take some examples. In this example, the value of the first octet falls within 192 and 223. So, we can say that this is a Class C IPv4 address. Another example, when we check the value of the first octet, we can realize that it falls within 0 and 127. So we can finally conclude that this is a Class A IP address. Now, go ahead, pause the video and take some more examples. Okay, good job. I hope you were able to write down some examples and identified their classes correctly. Now let's move on. For every computer on this simple network, one of these classes of IP address may be assigned. But what happens in case we have multiple networks connected together like this? How do we then identify and tell that this group of devices or computers belong to this network group? This brings us to something I call as parts of IP address. Remember the analogy of the student's index numbers, where it could be splitted apart, so could these IP address be splitted into two main parts? 1. Network address. 2. Host address. Before we continue to see how IP addresses are splitted, we have to understand what network address and host address does. Considering this simple network as an example, we have this network group 1 and this network group 2. If this host intends to send a packet to this host, that would not be any big deal because they are both part of the same network. But what then happens if this host intends to send a packet to this host on this different network? How will this devices or user be located on this remote network? That is when network address comes in. So, this device here, called a router, will use the network address of this network group to forward the packet. Now if the packet reaches this network, how can the message reach this host? That is when host address also comes in. So, the message will now be delivered successfully, using the host address of this device. I hope you got me right. So, in simple terms, we can say a network address identifies a network to which a host belongs, and a host address is also used to identify a specific host or user on a network. I will show you more about how these configurations are done on a router in later lessons. Now, let's see how IP address is splitted apart for network address and host address. To do this, we use what is called a subnet mask. A subnet mask is used to determine whether a host is on the local network or on remote network. In TCP-IP, the part of the IP address that are used as the network address and host addresses are not fixed. In this case, another 32 bits number is used to determine this. This is what is called a subnet mask. It is also written in dotted decimal ranging from the value of 0 to 255 and can be written in binary as 4 octet. In classful IP address, there are default subnet masks allocated to them. When I say classful IP address, I mean any IP address that falls within any of the IP address classes we learned earlier. Let's take some examples and see. Here are some examples of IP address classes and their respective default subnet masks. So, taking into consideration these IP address classes and their default subnet masks, we can then know how many bits are used for network address and how many bits are used as host address by looking at their respective binary values. When you look at these values, the ones represents the network portion of the address and the zeros represents the host portion of the address. This means that, for Class A address, 8 bits are used as the network ID and the rest are used for the host ID. Converting these bits into decimal, we have 255.0.0.0. With this, we can then conclude that the network ID for this class is this part, and the host ID is this. Similarly, for the Class B address, 16 bits are used as the network address and the remaining 16 bits are used as the host address. And converting this to decimal, we have 255.255.0.0. Therefore, we can conclude that this part is the network ID and this part is the host ID. And lastly, for Class C IP address, 24 bits are used as network address and only 8 bits are used as host address. And when we do the decimal conversion, we get 255.255.255.0. So, we can conclude that this part is the network ID and this part is the host ID. We are not going much deeper into subnetting today. We will learn the details in later lessons. But another important thing we must know is that, knowing how many net bits are used and how many host bits are used, we can then calculate the number of subnetworks we can create in our entire network using these IP address classes. Again, we can also calculate the number of hosts each subnetwork can have. Let's quickly have a look at that. The total number of networks a classful address may have is calculated by the formula 2 exponent n, where n is the number of network bits used. For example, when we take the Class A IP address, we can see that it has 8 bits used for the network. The first bit of the first octet is always set to 0. Therefore, the first octet ranges from 0 to 127. Meaning Class A addresses only include IP starting from 0 to 127 only. We can rewrite the IP format like this. In this case, we will have 7 net bits left to be used. So, following the formula, we have 2 exponent 7, and that gives 128. But the IP range 127.0.0.1 is reserved for loopback IP addresses. Subtracting the loopback IP address, we will now be left with 127. So, for Class A, we can create maximum 127 networks. To calculate the number of hosts, we go by the formula 2 exponent n minus 2, where n is the number of host bits used and the 2 represents network address and broadcast address. I will explain further how we get these 2 addresses later. When we count the host bits, we get 24, and using this formula, we get 16,777,214. So, for Class A address we can create a total of 127 networks, with each network having 16,777,214 hosts. And doing same for the Class B IP address. Class B IP addresses ranges from 128 to 191, and the default subnet mask is 255.255.0.0. Class B address has the first 2 bits in the first octet set to 10. We can rewrite the IP format like this, and counting the net bits we have 14. Following the formula, we have 2 exponent 14, which is equal to 16,384 networks. It has 16 bits left for the host bits, so, calculating the number of hosts, we have 2 exponent 16 minus 2. We get 65,534 hosts. Repeating same for the Class C IP address. The Class C IP addresses ranges from 192 to 223, and the default subnet mask is 255.255.255.0. Class C address has the first 3 bits in the first octet set to 110. we can rewrite the IP format like this, and counting the net bits we have 21, following the formula. We have 2 exponent 21, which is equal to 2,097,152 networks. It has only 8 bits left for the host bits, so, calculating the number of hosts, we have 2 exponent 8 minus 2. We get 254 hosts. We can see that, with Class C IP address, we can create a very large network but a few hosts. Now, I made mention of network address and broadcast address, yes. This is the reason why we have to deduct 2 from the total number of hosts we calculated earlier. This is because, for every IP address range, the first IP address is called a network address and is used by routers to find their routes to a remote network. Also, the last IP address is called a broadcast address. For example, if we have the IP address of 192.168.10.0 to 192.168.10.255, it means we can only assign 254 IP addresses, and the remaining will be for network address and broadcast address respectively. With this, the first IP address will be 192.168.10.0 representing the network address. And the last IP address will be 192.168.10.255, representing the broadcast address. We will talk more about these when we get to subnetting in later lessons. Let's quickly have a look at some types of IP addresses we have. There are 4 types of IP addresses. Namely, public IP address, private IP address, static IP address, and dynamic IP address. A public IP address is an IP address that can be accessed directly over the internet and is assigned to your network router by your internet service provider, popularly known as ISP. A private IP address is the address assigned to your devices internally. Each device within the same network is assigned a unique private IP address. Let's quickly see how you can assign an IP address to your computer. To do this, we have to get to the properties of the network adapter in our PC or laptop. We can do this in many ways. Open the Start menu and search for Ethernet settings. Select it to open. On your far right, click on Change Adapter Settings. This is one way of getting to your network adapter options on your Windows PC. Another way to get there is to open the system tray on the right corner of your PC. Right-click on the globe sign and click on Open Network and Internet Settings. Under Advanced Network Settings, click on Change Adapter Options. Another way to get here is to press the Window key and R on your keyboard to open the Run command pane. Now, type ncpa.cpl and press Enter. This will also bring you here. The number of adapters you will see here depends on how many network cards you have in your PC as well as some virtual cards installed. Look for the appropriate one. In my case, I have both wireless and cabled network cards installed. So, I will right-click on this one and go to Properties. Here, scroll down and select TCP-IPv4. Click on Properties. This is where you enter IP address on your PC. Here, there are 2 options. The first option is selected if your IP address is being assigned automatically by DHCP. In this case, I will select the second option, to assign it manually. We have 3 fields here, each of which consists of 4 boxes separated by dot. This is the first octet, second octet, third octet, and the fourth octet. Enter the IP address you wish to assign. For classful IP address, just click on the subnet mask field to automatically get the corresponding subnet mask. So, this is a Class C IP address, meaning that 24 bits are being used for the network portion. Don't worry about these fields, we will know what they are later. This is how devices on the same internal network talk to each other. In simple terms, private IP addresses let devices connected to the same network communicate with one another without connecting to the entire internet. For example, in this simple network, individual devices are assigned IP addresses which allows them to communicate. Now if any of these devices here want to communicate on the internet, then it would be done through a public IP address assigned to this router by your ISP. We will learn more about this as we progress. Now, any of the above IP addresses being public or private could be assigned in two ways. If the address is assigned manually and does not change over time, it is known as a static IP address. But if the address is assigned dynamically by DHCP, then it is known as a dynamic IP address. DHCP stands for Dynamic Host Configuration Protocol. It is a protocol that is configured to automatically assign IP addresses to devices on a network. With this, the IP address changes over time. We will end today's lesson here. I believe you have understood the concept of IPv4 addressing. Kindly subscribe to this channel and share for others to watch. This really encourages us to do more. See you in the next lesson.